Hey guys, so today we'll do another example with Jeremy's IT lab. Here we are going to configure a GRE tunnel between two different sites. So let's say, for example, you work at I don't know, Amazon at California, and you want to connect to Amazon at Florida. Okay, Amazon's probably a bad example. Okay, but let's say you have an office in California and you want to connect to an office in Florida. You could establish a GRE tunnel, and that would allow connection here. Uh, that the middleman, which would be the service provider network, they would not be able to see your messages. Um, and as you know, through the internet, these two offices would already have internet access, and they would already be able to, communicate with each other. But the packets would be able to be seen by the server provider and through being on the internet itself. So this will give us a secure method for, let's say we have important mail, or we want to just VPN from this site to this site without the messages or data going over the internet. This is another way we could do it. So let's go ahead and start off with router one. We're going to go ahead. First thing we should do is we do want to make sure there's some sort of route between router one and the service provider, and we'll have to do the same thing for router two and the service provider router two. So let's just see. I'm going to say do show IP route. And as you can see, we have the connected and local routes already established, which they're basically established um, automatically once you set up the router. But we don't have a route for the router reaching the service provider. So let's go ahead and configure a default route. And the way we're going to do that is we'll just say IP route 0, 0, 0, 0, 0, 0, 0, 0, and then we want to specify the next hop. So information that is coming off of the router to the next uh, device down the line heading towards the internet. This would be the next hop. So this dot one, and it's going to be part of the 100.0.0.0 network. So that's what we're going to type in, dot one. Let's make sure that worked. Do show IP route. And now we can see the S static route is configured. So any information that is going out of 100.0.0.0 network, I'm sorry, the 10. Any information that's going to the internet will be headed this way to this router. Okay, so we also want to do the same thing with the router and Office B. So we'll click on Office B router. And let's just see, enable conft do show IP route. And yeah, we have to establish a route between router 2 and service provider router 2. So we can say IP route o.o.o.o.o.o.o. It's going to be 200.0.0.1. Let's just make sure that worked. Do show IP route. So we have a static route configured. And let's check these out as well. Actually, never mind. There's a password block. We're not going to check those out after all. But Jeremy has these already pre-configured for us. But on the service provider network, this router would also need a route to this router, and this router would need a route to this router. So this could be two-way connection there. Okay, so now that we have established the static routes, let's go ahead and go back into R1, and let's create this tunnel. So we're gonna create the tunnel. Like it's basically the same how we would create an interface or even activate an interface, we'll say interface tunnel, and you can use any number here. You can say 0, 1, 100, 1,000, whatever you want. We'll just say 0. Okay, so the tunnel is now on. Well, it's changed state to up, but it still will not work. There's a few things we have to do here, so let's assign it an IP address. We will use 192.168.1.1 with a /30 notation. Oh, 266. There we go. We're not done yet though. We have to specify, we have to tell the router what is the destination for this tunnel. So where the where the once the traffic leaves here, where it's supposed to go, and what is the source. So tunnel source. You use question mark. We will use G/O/O/O because even though you see this here, this is just a logical connection. The data actually still does go this way, but for making it easier to understand, um, having it visually set up like this makes it a little bit more manageable. So tunnel destination. Now we're going to specify where the information is going to be entering this router. So it's actually going to be coming off of here. So we're going to use the 200.0.0.2 destination, like that. Okay, so the tunnel should now be established. Now let's see, I am on router 1. Let's see if we can ping the other side of that tunnel. Hmm. It might fail the first few times as far as like the first few like ping requests. Oh, actually, it failed completely. Okay, what could be the reasoning behind that? Actually, I already know. So now we established the tunnel for router 1, but we still have to do the same thing for router 2. So let's go ahead and do that. We'll say interface tunnel. And do you remember the number we used for router 1? Yep, 0. Okay. Let's assign it the IP address seen here. So the other end of this tunnel is 192.168.1.2. 192.168.1.2. Subnet of /30. And now we have to give it a source and destination. So the source, it's going to be going this way. So the source is going to be G0/0/0. And the destination is where is it going to end up at the end of the when it finally hits the office A. And that's going to be 100.0.0.2. Uh-oh. There we go. Now the ping should work this time. There we go. We do it again. We have 100%. Let's make sure it's the same way for the other side. So we have 100%. So now this tunnel is officially established. Um, that's cool and all that we are able to communicate, but we would still want to set up a dynamic routing protocol, such as OSPF or BGP or anything like that. That way, you wouldn't have just one device here, obviously. You would have probably like 20 plus, and maybe they're in different subnets, and it would just make it easier if you had like OSPF or something like that. That way, uh, the router dynamically learns the networks, and then it's able to communicate between Office PC1 and whatever other PC on the other side in Office B. So let's go ahead and establish OSPF on both routers. Okay. And um, let's go ahead and configure the interface going to the service provider network as a passive interface. And I'm going to say go/o/o because we don't actually want this interface to participate in OSPF. We would want the GRE tunnel to participate in OSPF. So we'll say uh, network 192.168.1.0, and OSPF utilizes wildcard, so it's basically an inverted uh, 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 subnet mask. So, and the inversion of /30 is going to be, well, /30 is going to look like this, right? Uh, the wildcard equivalent of that is actually going to be this /3, point 0.3. So that is how we're gonna say to OSPF, hey, these are the IPs that we want to have communication between with the OSPF. And we also want to specify the area. Oh man, let me do that. Let me fix that. Control A. Or say no. Okay, let's try that again. All I did is push Control A. It brings you right up to the where where it needs to go. So there we go. Let's say Control A again. There we go. So in this router, this interface, this network will be participating in OSPF, and we would also want any other subnet that you would want participating in OSPF set up here. So let's say network. We don't want this one set up. This is the network going to the service provider. We don't want that. Let's go ahead and use this one though. So we'll say 10.0.1.0, and the wildcard ask of /24 is actually going to be 20.0.0.255. And then we'll specify the area. We'll say do right. So OSPF is configured here. We're just going to do the same thing with router 2 on the other side in Office B. So I'm going to say exit uh, router OSPF 1 network, and we're going to specify this network here, and we're also going to specify this network. We don't want this one because it's the network going into the service provider, and we're also going to make this passive. So actually, let's go ahead and make the one interface passive first. Okay. I know the first time I actually did this before, um, I had mistakenly had these subnets involved with OSPF, and it gave me a loop, and I didn't know how to fix it. I had to use ChatGPT. But that's one of the cool things about learning this stuff. You end up even in like a simulation like Cisco Packet Tracer, you'll get in a situation where something's not working correctly, and then you have to kind of fix it and okay, I won't do that again. I will make sure this is like this or that is like that. Okay, so let's go ahead and configure the networks. Let's go ahead and do this network first. Because if I do this one before, if I do this one first, I don't have I didn't configure the line VTY to be to remove the logging, so it's gonna like just pop up, hey, this router is adjacent to this one now, so it's annoying. So let's say then we're also gonna specify the GRE tunnel itself. Okay. right. We'll give that a minute. There it goes. That's what will pop up. And then like while you're typing it, it's like boom, and it's just annoying. Okay, so let's go ahead and see the adjacencies. Make sure we're all good. Okay, so we will say, okay, so we are going to say, do you show IP OSPF neighbor? And we can see this one. This it's saying this router is our neighbor, which is what we want. It's through interface tunnel 0. The IP address is correct and it's full. So these should be transferring uh, data links between each other. So let's go ahead and say, let's make sure now with full adjacency between the routers via OSPF that PC1 in this subnet can communicate via OSPF all the way here to this PC. If it fails, it's okay. We'll figure out what is wrong and we'll fix it. Mm-mm-mm. So we have the ping reply. It's good. And let's do the same thing with this PC. Let's make sure we got, that they can communicate. And there you go. Like I said, this lab is brought to you by Jeremy's IT Lab. It's probably, if not one of the best sources to use on YouTube and Udemy to pass your CCNA. That's what I used, and I would highly, highly, highly recommend this stuff. All right, thank you guys for watching. Have a good day.